So, welcome students. Just a brief review of velocity time graphs. This velocity time graph represented by figure A, it's a horizontal line parallel to time axis which is showing that body is moving with a uniform velocity. This velocity time graph is a straight line having some positive slope which indicates that body is having some uniform acceleration and its initial velocity is 0 because it is starting from the origin point O. Here the object is having negative slope, so we can say it is moving with uniform retardation and it is having some initial velocity and non sorry 0 final velocity, some non-zero initial velocity. So here we can see that if this angle is greater than 90 degree, it's a downward sloping line. It is having a negative slope, so its acceleration will be negative, which is signifying that it is acceleration is it in the opposite direction to that of velocity. Now here we can see it's a straight line having some positive slope, so body is moving with uniform acceleration, but here the initial velocity is not 0. It is having some initial velocity which is non-zero. Here in this graph E, velocity time graph, this graph is it's a curved line. So when the velocity time graph is a curved line, it means the body is moving with non-uniform, or we can say variable acceleration, because the slope of this graph is changing and the slope of velocity time graph indicates acceleration, so acceleration will also vary. Here the body has 0 initial velocity but moving with a non-uniform or variable acceleration. Now what do you say about this graph? There are different regions shown. First region is from O to A, second one is from A to B, then B to C, then C to D. So, as we can see that from O to A, velocity is 0, which means that the body is at rest or stationary. There is no change in displacement. Okay, now when from A to B, the graph is a straight line having some positive slope. It means slope is constant, so it means that it is moving with uniform acceleration from A to B. Now from B to C, graph is a horizontal line parallel to this time axis. BC and this time axis, they are parallel to each other. Therefore, we can say that there is no change in velocity. Velocity is constant, uniform from B to C. Slope of this line is 0. That's why acceleration is 0. Now, from C to D, we can see that this angle is greater than 90 degree. This is a downward sloping line, so its acceleration is negative and the body is moving under uniform retardation or deceleration. Now, the question in this graph, consider the motion of object whose velocity time graph is given in the diagram. What is the acceleration of the object between time instants t is equal to 0 and t is equal to 2? So we have to find the acceleration, and when the velocity time graph is given, we know that its slope indicates the acceleration. Acceleration is given by the formula change in velocity upon change in time. V velocity at t2 minus velocity at t1 divided by t2 minus t1. This is the formula for finding out uniform acceleration or constant acceleration. Now, since velocity is a vector, so is acceleration. Now, first of all, we will find out the velocity at the instant t2. Now, t2 is 2 seconds. So, we will start from this instant 0, 2. So this is the instant when the time is 2 seconds. We will draw a perpendicular line to the time axis and extend it in the upward direction. Where it intersects the graph, we will draw a perpendicular line to the velocity axis, and here we will note down the value of the velocity. So velocity at, you can say velocity at 2 seconds will be equal to 8. So velocity at t is equal to 2 will be equal to 8. Now we know that velocity at t is equal to 0 is 0. So velocity at t is equal to t1. t1 is 0. t1 is 0. t2 is 2. So we will replace velocity at t is equal to 0 by 0 divided by t2 is 2 second, t1 is 0. So 2 minus 0. So acceleration comes out to be 4 meter per second square. Now another question, it is the velocity time graph of a moving particle. Total displacement of the particle during the time interval when there is non-zero acceleration and retardation. You can see that from this point to this point, velocity time graph is a horizontal line parallel to time axis, which means that velocity is uniform, slope is 0, so acceleration is 0. Here from this point to this point velocity acceleration is non-zero, and from this point to this point there is retardation which is non-zero, and again from this point to this point acceleration is 0. So how do we find the displacement for this portion? Suppose if you name it as A, B, C. So we have to find displacement for this portion A, B and C. Now we had learned that displacement is nothing but product of velocity and time. And if we are having a graph, the product of y-axis and x-axis is nothing but the area under the graph. So the product of velocity and time will be nothing but the area under this graph A, B, C. As you can see, there is a trapezium forming here, so we can find out the area of trapezium, which is equal to half sum of parallel sides plus the distance between these two parallel sides. So we can take it as two trapeziums. Okay, two trapeziums and equal trapeziums, and add their areas. So area comes out to be half. Okay, half into, these are two parallel sides, its magnitude is 1, its magnitude is 4, so half into 4 plus 1 5. Okay, and then this height will be equal to 30 minus 20, which is 10. So half into 5 into 10 gives us 25. Now as these two trapeziums are equal, so we can say that area of two trapezium will be equal to 2 into area of one trapezium. So 2 into 50 we can say. Or in other way we can also find out the area under this ABC curve by assuming that there is one triangle, by breaking it into a one triangle and then one rectangle. First find out the area of this triangle, half base into height, then find out the area of this rectangle. So area of triangle will be equal to half, base will be 40 minus 20, which is 20, and height will be equal to 4 minus 1, which is 3. You will get half into 20 into 3 plus this is the area of rectangle. So area of rectangle will be equal to length into breadth. So length will be equal to 40 minus 20, which is 20, into breadth, which is 1. So you can say it is, sorry, 40 minus 20 is 20. And now length is 20 and breadth is 1. So area will be 20 into 1. When will you add them, the area comes out to 50 meters. So we can say that the displacement of the particle during the time interval when there is non-zero acceleration and retardation is equal to 50 meter. This is all for today's lecture. Thank you.